So now for factoring polynomials, is the reverse of what I just did. You usually have a longer expression and you want to make it back into before you expanded the product. So the first thing I want to show is like factor trinomials. So we have some basic ones that we use, and
what is a trinomial? I didn't get
trinomial
to the
is like the, what's the name of a trinomial, right? Trinomial is like the last line, the one at the bottom. That's called square root of a difference. Do you see that on the right hand side of the equation? You have x squared minus 2xy plus y squared.
Yes.
So you have three terms there, right? You have the x squared, you have
Yes.
the negative 2x, and you have the y squared. So that's why it's called trinomial. There's
Three different nomials.
Yeah, three different nomials, basically. Yes.
Okay.
And then the square of a sum too. That's also a trinomial.
Okay.
And then the upper two are not trinomials. They are probably binomials, I think, because there are only two, that you have two terms.
Okay.
Yeah, so that's the name, what's called trinomial. So basically they're going to ask you to factor square of a sum or factor square of a difference. So there's something called, it's kind of like a pattern recognition thing. So you go from the left to the right, like when you say a times x plus y equals ax plus ay, right? When I have x plus y times x minus y, it gives you x squared minus y squared. I highlighted it because it shows up a lot to factor this kind of polynomials. They will give you x squared minus 4 and want you to factor it into x plus 2 times x minus 2. Stuff like that. Yeah. And then the other one is when we expand x plus y squared, we will get x squared plus 2xy plus y squared. I don't know if everybody can say. Can I go back to the whiteboard just a sec? I want to make sure. So we have x. Let's try this. Yeah, x plus y squared. Yeah, what does square means? It means the number. This thing is multiplying by itself, right? So it's x plus y times x plus y, right? So now let's use a distributive rule, and then let's do these guys first. Yeah. So I'm going to get x times x is x squared. Is everybody okay with that? The first one. And then x times y is going to be xy. There's no way we can write this. Yeah. So I did the first part. Now I have to do the second part, which is gotta do the y multiplying this side too, right? So I get plus yx, right? Y times x plus y times y, which is y squared. Yes?
Yes.
Are we good? So then what we need to notice is something here. xy and yx are the same. It's like saying 2 times 3 is the same as 3 times 2.
Okay. I was going to ask if that was the same nomial.
Yeah, because it's multiplication, right? If you have about addition too, actually. Yeah, 2 plus 3 is 3 plus 2. So that's what we call, I think, commutative property or something. So here we can write it as, so that gives me, these two give me 2xy, yeah? So this is why I end up with x squared plus 2xy plus y squared, yeah, which is what we had on the slide. Now, what I want to say is now, if you plug in y equals to 1, what this will look like is what we just did was going to look like this. Yeah, x plus 1 squared. Yeah, because I'm plugging y equals to 1 everywhere here. Yeah, so that's equal to x squared plus 2x plus 1. Did you see that? Like I plugged in the value y equals to 1 everywhere that had a y, like here. This becomes this, and this guy here becomes this guy here. Yeah. So why is this? Why am I showing this? It's because when we say, hey, factor this guy here, x squared plus 2x plus 1, then you know, hey, factoring it out, it's actually x plus 1 squared. I go back this way when I say factoring. This is what I mean by factor x squared plus 2x plus 1. I reverse the process and say it actually came from a multiplication of x plus 1 times x plus 1.
And why is x plus 1 a smaller factor than, I mean, I think I know, but I just want to hear from you. Why is x plus 1 a smaller factor than x squared plus 2x plus 1?
Oh, yeah, sorry. Yeah, because like this one, the power of x here is 1. And the power of x, the highest power of x here is 2. So what we are trying to do when we say we are factoring, we're reducing this guy to a smaller number. So each factor, each multiplying factor is now smaller, right? Because this one, x plus 1 squared, is x plus 1 times x plus 1.
And
right,
so it would be totally fine. Would it be totally fine to have x plus 1 to the 16th power, if it's x plus 1 in parentheses to the 16th power, versus x squared plus 1 to the 3rd power, because we don't want to have that. Does that make sense? We don't want to have x to a power higher than 1 inside the parentheses when we factor.
You may wait. If you have 16, we're never going to see 16, right? Okay, so in this course,
Oh, it doesn't need to be 16.
I know. But no, but I know your point.
And I'm not really a student, so Danielle and Solstice, we can move on if
be like here, this is if it's like this, if you say, hey, this is my polynomial, right, to the power 16, this is already factored as much as possible, because what I have here is x plus 1, and I can't break x plus 1 into anything smaller than that, you know. But however, if I had x squared plus, 2x plus 1 times x squared plus 1 to the 14, you know, these two are the same, right? But this one, the second one, is not completely factored out yet, because I know that this guy can still be factored down further to x plus 1 squared. You know, it can be broken down as a product of other polynomials.
You're like a magician. I love it.
What do you mean? So they are the same, right? Like now I can add them and it's the same. But here, this guy is not completely factored yet, because I can still break this down. But I can't break down x plus 1. Yeah, can't. But we'll never, guys, never worry about this, because yeah, it's like Professor Ben causing trouble. We are not going to have 16 ever. Like the maximum that we'll ever factor is probably up to squared. So that's it. But I do want to note something though. I want you guys to notice that what I said of similar terms, I was just talking about powers of x, but you need to see the powers of x and y, like everybody's powers. So this guy here, x squared y, is different from x times y. I cannot add them together, okay? And these two are also different from x y squared, you know, which are also different from like y cubed, whatever, you know. It's like, hey, all the powers of all your x's, y's, p's, w's, whatever, need to be the same in the product for me to be able to add them up or subtract them. Now, each single power of every variable needs to be the same in that expression for me to say, okay, these two are similar terms, and I can group them and add them or subtract them. Okay, in case of doubt, don't add, you know, because, yeah, I would say, because you might be messing it up, right? Expanding is not wrong. It's just ugly and hard to interpret, but it's not a mistake. Okay, so let's go back to the so like one of the examples I have below, the next slide is, hey, factorize the expression x squared minus 16. So we see from the previous slide that when you have the difference of two squares, like the one that I highlighted, it's when you have the difference of two squares, x squared minus y squared can be factored into x plus y and x minus y. So x squared minus 16 is like x plus 4 times x minus 4. And then if you feel like, why is that, right? My suggestion is get pen and paper and then multiply x plus 4 with x minus 4, x plus 4 times x minus 4 out and see what you get. And then you'll see like stuff gets canceled out. And then in the end, you have x squared minus 16. Yeah, is that okay? Do you guys want me to do that out in on the whiteboard? I'll do it out. Like what the hell? Like I'm already doing it. I mean, do it. This one is nice. I like to do this one. If things get canceled out, it's a much better feeling. Like let's do right. Let's just check that was I had x plus 4 times x minus 4. So I would suggest to draw. Let's draw the lines, right? I'm going to do this guy here. And then this guy here, and then I'm going to do this guy here and this guy, just so that I don't forget anything. So in the end, I should have 4 terms if I made everything right? So the first guy is going to be x times x is x squared. And then don't forget this negative x here, right? So that's the second one is negative 4x. Okay, and now for the purple ones, I have plus 4x. And then plus 4 times negative 4, that's negative 16. Is that okay? This is 4 times negative 4. All right, this guy here. This guy, when it times this guy, it's going to give me negative 16, right? So now what happens is, look at these guys, minus 4x and plus 4x. These do get canceled out. So this, because this is a negative 4 with a plus 4 multiplying x. So they are going to give me 0 times x. So that gets canceled out. So finally, I get this guy here, x squared. And then I get negative 16 here. Yeah, so I can show like it's going to be, so when we know this, we know how to factor all these guys that we can get all these x squared minus 1. You know it's going to be x plus 1 times x minus 1. If you get x squared minus 81, you know this is going to be x plus 9, oops, times x minus 9. Now it works for everything. If I can even go like a little bit more ambitious, like 4x squared minus 25. Like, oh my God, right? But it's like, hey, 4x squared is 2x. So this is going to be 2x plus 5 multiplied by 2x minus 5. I'm using the same pattern, the same formula over and over, just with some variation. Yeah, okay.